Bonjour, welcome to Wahsa Lesson Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you are welcome to call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You're always welcome to join me through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 3 till 4 in the afternoon, and we are in week 1 of our 9-week course. So just to let you know what work to submit once you get to that point, the key questions are the only questions in your book that we comment on or that are listed. So they are the ones to submit for marking. So all of the questions are listed at the end of each of your IL lessons. So you have the IL booklet package and it has a list of the questions that you need to answer. So please do all of them. They are found throughout your workbook. So some of them are check your understanding questions, some of them are activities, some of them are review questions. So just make sure that you're looking at the end of the IL package for each lesson and finding all of the questions to complete. Please show all of your work, all of your steps, all of your thinking. This way I can give you credit for all of your understanding. If you just give me 1 or 2 words, I might not be able to understand really what it is that you're saying and what you're meaning. The more information you give, the more marks it is easier for me to give you more marks. Make sure you're actually answering the question. It can be easy to get sidetracked or to pull out a couple of words and think you're answering the question. So just make sure you're actually answering what the question is asking. You can do it by hand or electronically. So if you want to write in the workbook, feel free to, that is fine. It is your workbook. So you can write it and then scan it or take a picture and send it to me. Or you can write your questions out by hand if you prefer to do that on a piece of paper. Or you can also type things up electronically in Word or Google Doc are the programs that are easiest for me to work with. But if you don't have access to those, you have access to something else, let me know. We can troubleshoot to make sure that I can actually open your files. That's the most important part. All right, so how you submit your work for marking once you've completed it. So there's 3 methods. The first method is to scan and send your work in electronically. So you scan your completed work in, and if you have a smartphone, you can use either the iPhone Notes app or the Android Google Drive app. They both have scanning functions, and this just makes it a little bit easier to send instead of sending a picture. If you need to send a picture, that is totally fine too. And then you can email it to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. Second method is to drop your work off into Lookout. So there's an outdoor mailbox at 74 Front Street at the side entrance of our building. We are the big red building next to the post office, and we have a small white mailbox next to our side entrance. So you can just put it in there and I will get it. The third method is to hand it into your DEC. So your DEC can then either send it through the Express or they can fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and YouTube channel are under the name bslatewahsa. So that's how you can find me. You can friend me on Facebook, subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our classes. So after they air, our classes are recorded and I upload them to YouTube, and then I share them on Facebook so that you can find them there, just to make it a little bit easier to make sure that everyone can access the replays if they'd like to. They're on a playlist on my YouTube channel, and that is called SVN3E. And there also is a playlist under that called supplementary videos that have other videos that we have watched in class there. So you can rewatch videos if you'd like to, without watching the whole class, but just if you want to check out some of the videos that we've watched in class there. I have them all linked on a playlist there so that you can find them. Science is really visual, so connecting to the videos is going to set you up for the most success. So either joining me through Zoom and watching it live, or watching the replays on YouTube is really going to make you make the most connections and really understand what it is that we're talking about. I try my best to include as many pictures and videos so we can actually see what's going on. I think I find is really helpful for understanding, opposed to just having just talking about it and hearing about it. Being able to see really makes those connections stronger. So if you don't have access to reliable internet, let me know, and then I can send you a copy of the recordings in another way so that you can still access them. So if you have any questions or concerns, please reach out to me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE @nnec.on.ca. My Facebook is bslateWahsa. My phone number at the office is 807-737-1488. And the toll-free number there is 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 4 p.m. So I'll get back to you within those hours as soon as I can. If you need to connect with me outside of that time, let me know and we can schedule a time that works for us so that we can connect if that's something that you do need. Before we dive into our new content today, I just want to talk about my positionality. I think it's really important within the science course that I acknowledge my white privilege. So me as your teacher, I have white settler ancestry. And so that just sort of shapes the way that I look at science and the way that I understand science because of how I was taught as a student. And then also just the way that I walk in the world means that my understanding of the world is very likely different than yours. So I do live in Northwestern Ontario on the traditional territories of the Anishinaabe people. So I am attempting to learn as much as I can in a respectful way. But this is my first time teaching this course. So I do have lots to learn and to unlearn as well. So I'm a work in progress. So I will do my best, but I want to acknowledge that just in case I fumble along the way. Also, our textbook and the workbook that you are answering questions in is Eurocentric. So it's often gives examples or talks about scientists or people from sort of white supremacist idea in terms of that is the experience that they are connecting to, which is problematic. They also may use some problematic language, and I've found they ignore the Indigenous and Inuit and Métis knowledges and experiences. So that is problematic and concerning. So I will try to integrate as many Indigenous, Inuit, and Métis knowledges and experiences as I can. But as I said, I am a white person and therefore don't have a really deep understanding, and I'm doing my best. But if there's anything that I do incorrectly or ways that I could learn, I accept that and would love to hear that in order to improve this course. So just connect with me and see what we can do to make this all better, make this more representative of our student population. All right, so we are continuing with Unit 1 today, we are the guardians of Earth spheres. So just a little recap that Earth is a superorganism, the way to think about it, and that all the living things and non-living parts of the Earth keep it healthy. So they all work together to keep Earth healthy. And all of the Earth spheres, the land, air, and water, are connected to one another and to us, and also to other life forms. So in this unit, we're learning how the Earth spheres work and how people affect them. So last lesson, we learned in detail about soil, air, and water. And then today we're learning about the impacts that humans have on those. So we're on lesson 2 today, and our lesson is called Effects of Human Activity on Soil, Water, and Air. So our learning goals for this lesson are that you will understand the effects of human activity on soil, water, and air. That is our sole focus. You know that you've met that learning goal because success criteria of 1, I can explain the impacts of deforestation, urbanization, erosion, chemical fertilizers, and pesticides, and industrial chemicals on soil. 2, I can explain how humans create water pollution. 3, I can explain how the burning of fossil fuels has created the climate crisis and the impacts on humans and the natural environment. So to start off, the composition of soil, water, and air usually changes very slowly over thousands of years. So things do change, but it's a very slow process. Human activities, however, can change soil, water, and air quality in just decades or days. So we can have a huge impact. The things that we choose to do can have immediate and intense impact on soil, water, and air. These changes have long-lasting effects on the living things, on the environments, and on climate patterns. So the effects also impact our own societies and quality of life. They can become permanent before we fully understand the dangers that they pose. So it's really, we need to be really careful about the decisions that we're making because we don't necessarily know the impacts that they're going to have in the long run. And if you think about over the last 100 years, how much our society has changed and the increase of burning of fossil fuels, the increase in population, all sorts of things, and how that has impacted our earth. And we don't even know what the next 100 years are going to look like at all. We have no idea. And so we aren't really planning for the 7 generations in front of us, at least as a society, we are not. Some individuals, some small communities, some communities maybe, but I don't believe as a society as a whole, we are planning for the next 7 generations. And that is really problematic. We need to be thinking ahead and not just thinking about the now. All right, so first we're going to look at soil. So soil is the foundation of our food. The percentage of earth lands use, so this is an image from your workbook, is it's broken up into 12% farmland, 26% pasture land, so where animals can roam and eat and grow, 26% forest, and then 36% that is unsuited for agriculture or development. So only 38% of our land area is available for either growing crops or grazing animals. So that's what we eat. Only 30% of our overall land is available for that. So further, if we look at globally, another way to look at this is I found this image from our worldindata.org. And so here we're looking at global land use for food production. So first we have the Earth's surface, and this bar is cut off in order to be able to look closer. So 71% of the Earth's surface is ocean. So this bar should be about 3 times the amount, 2.5 times the amount of the land that it is. So that's already a big chunk that we don't have access to in terms of food production because it is covered in ocean. Yes, we can eat seafood and eat both plants and animals from the ocean, but we don't to the extent that we could. So really most of our production is on land. So 29% of our earth is covered in land. And then 71% of that 29%, so this is not 71% of the whole earth surface, this is just 71% of the land surface is habitable. So 10% is glaciers and 19% are barren land. So things that we just don't have, like deserts and exposed rock, beaches, dunes, things like that we just don't live on and can't grow food on. And then of that 71% that's habitable, 50% we use for agriculture, so for farming. And then 37% is forests, 11% is shrubs, 1% is urban built up land, and 1% is freshwater. So only 1% of our habitable land is freshwater, which is just important to remember in terms of use of water, which we're not talking about right now, but it's also important to remember. Then of that 50% of agriculture, 77% is livestock, so meat and dairy, and 23% is crops. But then in terms of how much food we actually eat, globally, we eat the majority of our world eats from plant-based, gets most of their food from plant-based. So 82% of the world, of the world, 82% focus on plant-based, opposed to 18%, which eats more of a livestock, is more prevalent in their diet. So 23% is being used for 82% of the calorie supply that we need. So that's just really interesting to look at in terms of it's not really proportional to what we actually are doing. So a very small amount of our agricultural land is producing a lot of our food, and a lot of our agricultural land is producing just a little bit of our food, and that isn't necessarily beneficial or looking useful if you're looking at a global perspective. So that just gives you a little bit of a different view about how we use our soil, how we use our land in terms of our food production. All right, so then looking in detail of soil. So topsoil is the most fertile part of the soil. So it's found just below the surface. It's essential for the growth of plants, which is our food, aka our food, but also our food's food, right? If we're eating animals need to eat plants. So it is essential for that growth. So therefore it is essential for all of the food and all of the cycles of life on Earth. Here is a map that shows the number of agricultural operations in Canada. I couldn't find a more recent map. This is from 2015. This is the best I could find. So you can see that these red dots are representing agricultural operations, 50 agricultural operations per dot. So it's not just one, but you can see that along the southern part of Ontario and Quebec, a little bit in Maritimes, and then a little bit then throughout the prairies, southern Manitoba, Saskatchewan, and Alberta. The yellow part is agriculture exhumed. So it is not necessarily direct agriculture operations, but it's related to it. So it's connected to it in these areas. And then you can see in southern BC is also where we have farming. But humans are constantly destroying it. So topsoil is essential, and we can see those areas in that map where it likely is, because that's where the farms are, but we are also destroying it constantly. So we're destroying it through deforestation. So here's an image of where some logging companies have done some clear cut, so they cut all of the trees, and this then leaves open for erosion, so that soil gets washed away and broken down because the trees aren't there to protect it anymore. And then urbanization. So we go through, we cut out all the trees, and then we build up cities and towns. You'll also notice here's a map of population, and you can see that in Canada, the majority of the population, where we have our biggest towns and cities, where we live mostly, is on that same area where we had lots of farming. So it's partially because we live close to where we can make food, but also that means that we're using that soil, that the best soil for growing is also where we have our towns and cities. And so that's problematic because we are then clearing out that topsoil. We're destroying that land that would be best for growing our food. And that means that we become dependent upon other places in order to provide our food, because we have built up cities and not engaged in agriculture. We haven't really figured out how to do it in a way that sustains our soil. Then erosion, as I said before, in terms of connected to deforestation, but here you can see where the soil is actually washed away. There's nothing to hold it down. And then water comes along, wind comes along, snow, and it moves the soil, and that changes the landscape, and it changes our ability to how we farm And even how we farm can actually cause erosion because of how we plant crops and things like that. And so we can actually have erosion within farmland because it sort of strips the nutrients and the health of the soil. Then we have chemical fertilizers and pesticides. So here's some pictures of farming. So we have a tractor that is spraying a chemical fertilizer. So you can see this big spraying machine that is spraying something on the crops in order to help them grow. But that means that we're introducing those chemicals to the soil, and that might not be beneficial in the long run. It may be beneficial in the immediate, but that means that we're spraying our food and as well as the soil with these chemicals, and we don't necessarily know the outcomes, or we're not necessarily choosing the best options. We might be choosing the most convenient and the most affordable or cheapest, but not necessarily something that really is beneficial in the long run. The same way with pesticides in terms of getting rid of pests, bugs, and rodents and things like that. So we spray our plants to help them grow and protect them, but that means that we're introducing those chemicals into the soil. And what is that going to mean overall? Looking at this picture, you see how these people who are spraying have such like protective gear on. They have hats and probably face masks. We can't really see them, but because they're all looking down, the gloves, like full on body protection. And so it's like, well, if we're protecting the people who are spraying so much, which is good to protect those people, but is that what we want to be introducing to our food and into our soil? And then we have industrial chemicals. So in our industry, so in factories and things which we're fairly dependent upon as well, though that waste often gets introduced into the soil, whether it is intentional, not intentional, legal, not legal. It has an impact on the soil, and that really affects us overall. Everything's interconnected, right? So if we're introducing chemicals and pollutants into the soil, then we are introducing them into our cycle and into the nature cycle in general, and that's really going to impact it overall. So it feels kind of hopeless when we list it all off like that, but we can help. There are things that we can do. So we can, yes, logging needs to happen, and I'm not saying to never log, but we can reseed forests with fast growing plants so that they have a chance to so the soil doesn't get eroded. The fast growing plants sort of give ground covering and protect the ground. So that's really useful. So here's an image where you can see where logging has happened, but there is still growth happening in those areas. And so that's protecting the soil. We're focusing on protecting the soil and not talking about logging and forestry. That's another conversation. Right now, we're just talking about the soil, but this is one way that we can protect the soil so that erosion doesn't happen and those nutrients and the soil, the healthy soil, the top doesn't get washed away. Farms can use various methods to protect soils so that erosion doesn't happen. Here's an image of some different ways that you can actually shape your crops so that the soil actually does get protected. So there's terracing, which is sort of things done at sort of on levels, and then contouring planting or strip cropping. So things not all going in the exact same direction, but in different curvy ways in order to benefit the soil and not have it all just stripped away. Alley cropping, where we have different crops together to support each other and to protect the soil. And then windbreakers, where we plant tall trees around our crops in order to protect the soil from the elements. Mines can be filled and covered in topsoil and then reclaimed. So here's an image of a gold mine in the States, where you can see this picture on the left, where it is all stripped and barren sort of looking. And then now over time, with some support, you can see it has come back as green, and plants are vibrant and hopefully thriving. So there is things that we can do to shift from a barren land to a green landscape. And then polluted soils can be removed and treated, not necessarily always, but sometimes. So there are various methods. They're fairly complicated methods, and to actually do it, but you can scoop contaminated soil out of the ground and then process it and try and treat it in order to remove the chemicals and improve it to return it back to nature. Right, so that's an overview of how humans impact soil and what we can do. Now let's look at water. So water pollution. So human activities pollute the water. This shouldn't be news to you, hopefully. So this includes chemical runoff from mining and pulp mills. This includes leaky dump sites, industrial activities, fracking, which is when we try to it's a way of getting natural gas out of the earth. And so we pump really high pressurized water with chemicals in it into the earth that then cracks and erupts natural gas, which we then catch. But it means that the water that we're using to do that becomes really polluted with the chemicals that they inject in order to be able to do that. So you can look at some videos and you can see, or maybe experience it if you're in an area where fracking is, people can like open their taps in their homes and then like use a lighter or something and light the chemicals that are coming out of their taps, light their water because of the chemicals that are in their water. It's pretty intense. Then even just like recreational activities like boating are introducing chemicals into the water, which is concerning. And then also chlorine is added to our drinking water to kill bacteria for our health, but is also linked to carbons, which are known to be causing cancer. So something that we're choosing, a chemical we're choosing to add to our water in order to clean something, but is also, once we consume it over time, is impacting our health. So that's something to be aware of and the decisions that we're making. And then finally, pavement and concrete and storm drains. So in our towns and cities, they funnel the rainwater. So when the rainwater comes, we direct it all to go into the same place. But as it's washing down the streets and down the land, it collects gasoline, oil, road salt, and then collects all of that, washes it all together into the storm drains or into the sewers. And that then takes all those toxins to the closest body of water, which for many folks is also our source of drinking water. So that's just something to be conscious of in terms of the decisions that we're making, in terms of the way that we've structured our societies, is that we haven't really been thinking about the impacts of the actual soil and water for the solutions that we've come up with. So here is an image. It's I tried to find a colorful image of water pollution sort of the cycle, but the one in your booklet is really the best that I could find that didn't have a whole bunch of other jargon on it. But so we can see that all of the ways that we impact our water. So water supply plant is putting pollutants in, a dump, waste site leaches into the water, leaches into the soil into the water, pesticides and fertilizers go into the water and leach into the soil, and then also can burn off into the water. Manure from grazing animals, grazing herds, that is problematic for water as well. And then boaters, so all of that goes into our lakes, which then goes into our groundwater, which then goes into our well water. So that's sort of a country version over here on the left. And then also we have acid precipitation, which we'll talk about, which then enters our groundwater and our surface water. And our power plants or industries are putting smog and chemicals into the air, which then rain down on us. And use of automotives, so gas, landfills, urban runoff, all goes into our lakes and our streams and our oceans, and then all gets contaminated and moves around and cycles back. So that water cycle that we talked about, any contaminants also cycle through that water cycle and has a greater impact. Great, so here are the key questions on page 12. So these are the check your understanding questions, 1, 2, 3, 4. Which will talk about soil and water. So you can pause the video now and go and answer those questions if you'd like. And now we're going to look at air. So when we're looking at air, we're first going to look at fossil fuels and just remember what fossil fuels are. So they're coal, oil, and natural gas, and they are the source of most of our energy. So when we are consuming energy, using things, creating anything that is not human or animal powered, basically we are most likely using a fossil fuel. Not necessarily, there's hydro, there are other ways, there are electric cars, things like that. Like we are moving away to other, not just using fossil fuels, but we're still very, very reliant on fossil fuels. So here is a diagram that shows how coal and petroleum, which is oil, and natural gas are formed. So for coal, this image says 300 million years ago in a swamp, before the dinosaurs, many giant plants died in swamps. So we had a bunch of plants, they died, and then over millions of years, the plants were buried under water and dirt. So the dead plants were on the ground, dirt, water. 100 million years ago, this all compacts those dead plants. And then as it compacts, it gets pushed down lower and lower in the earth. And so heat and pressure are added to it, and those dead plants now become coal. So coal comes from million-year-old dead plants that are deep in the Earth's surface or below the Earth's surface. Similarly, petroleum and natural gas are formed from same 304 million years ago. Tiny sea plants and animals died and were buried on the ocean floor. Over time, they were covered by layers of silt and sand. Then through time, those were buried deeper and deeper over more animal remains, by more silt and sand, by more water, and the heat and pressure as they get pushed down and down and down, turn them into oil and natural gas. So now we need to drill down through all those layers of layers of the soil and surface in order to find those deposits. So this is why when we say that fossil fuels are not renewable, is that it takes millions upon millions upon millions of years in order for these things to be created. And we can't just be like, oh, in just 10 years, we can create this again. No, this is just unfathomable in terms of the time frame and why they're not renewable. So when we burn fossil fuels, we do this in lots of different ways. So many human activities involve burning fossil fuels. So driving cars, boats, airplanes, heating and cooling our buildings, creating common products. So lots of products use fossil fuels, but then also in the production of those, we burn fossil fuels in terms of the creation of those. So working in factories burns fossil fuels. And in general industrial use, lots of industrial use burns fossil fuels. So what happens is that that coal, that oil, that natural gas, all those elements that were compressed, we release those chemicals into the air when we burn them. So these are called emissions, and they're nitric oxides, hydrocarbons, and ozone all mixed together and create smog. So that's the releasing of the dead plants and animals components from millions of years ago is how we release all those elements into the air, and that's what creates smog and pollution. I find it really interesting in this graphic that's in your book that we have a house, a car, a factory, which is smaller than the car, and a barbecue, which also is bigger than the factory, showing as the ways that we create smog. Yet industry is one of the leading causes of smog and air pollution. So it just sort of seems disproportionate in this image that we have like individuals that it's sort of like making you seem like, oh, we have really huge impact. We do have an impact, but also our industry, the bigger factories, the things that we are creating are what really create air pollution. But in this diagram, it sort of shows that it makes you think that there's a lot of responsibility to individuals opposed to organizations and corporations. So change needs to happen by the individual. Definitely, we still need to be conscious and change individually, but also corporations and governments really need to take lead for this to actually make a change and actually do something that is going to be worthwhile. It can't just be, if you search about how can we change pollution, or how can we change the climate crisis, a lot of things will be like, you'll get individuals, do less laundry, or eat less meat, or turn off your lights, or don't drive your car as often. And all of this is true and does have an impact, but it's also about the products that we buy and the pressure that we put on our government in order to set environmental laws, and not just be conscious about that, and the decisions that they're making is really, really important. And so we have a lot of power in terms of pressuring our corporations and our governments to be making environmentally friendly decisions. And it's not just about the individual day-to-day actions that we have, but those bigger picture actions. So here is a really good visual that there's a lot out there, but I liked this one about during COVID-19, the COVID-19 quarantine, particularly in immediately, like in March 2020 and April, so about 2 years ago, there were a lot of things floating around the internet that were just showing how much of an impact that the fact that a lot of the world was shut down, a lot of the world that creates a lot of pollution was shut down, that we were forced to stay home, encouraged to stay at home in order to stop the spread of COVID-19. And then our environment just thrived. So this, I believe, this is a city in the States somewhere, and you can see on the left, we have this gray, there's not a filter. This is a gray, thick air. You can see it's just this, yeah, I don't know how to describe another way other than thick. The air pollution is just, you can hardly see through it. Whereas during the COVID-19 quarantine, that the air just clears up, and it's like night and day almost. And you can see the details of the city, and you can see blue sky, and you can see the vibrantness of even the trees, and it's just dramatically different. And so it means that we can do things. We do have the power that if we just, we can't just stop, but if we start to be making more environmentally conscious decisions, we could change the pollution that we've already had, the impact on the earth that we already have. It really could be changed. We can confront it, but we just need to make some dramatic decisions and really focus on that in order to prioritize the health of the earth overall. So we're going to watch a video about asset participation. We talked a little bit about it before, but this is just sort of connected between air and water as well. And so we're going to watch this video to connect all of that to see how pollution cycles through.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, even dry materials that settle to earth. Acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances.
So that video just, oh, sorry, my bad. Just drives home a little bit, gives you some context and sort of seeing a little bit of the images of how pollution cycles through our system and how it is sort of a domino effect in terms of what it affects and the impacts. overall. All right, so then the next step we're going to talk about is the climate crisis. So this is also, people have referred to this as global warming, but it's sort of a combination. It's not just global warming, but it's the impacts of global warming. And so it's an overall climate crisis opposed to just the earth getting warmer, which if you think about it, there have been some folks out there who are like, but it's not getting warmer. I mean, we're expecting the supposedly a historical snowstorm here in the middle of April. And so that doesn't feel like the world is getting warmer, but the impacts of the earth overall getting warmer is creating climate crisis, which is shifting our climate overall. So here is a graph that shows how the earth has been getting warmer. So the annual mean land and ocean temperatures above or below the average from 1850 to 2020. So you can see that in 1850, so this is almost 200 years ago, the earth was below, sorry, negative 0.6 Celsius and up to 0 was a lot of the average land temperature and ocean temperature. Sorry, having my brain was just fuzzing. And then we've got a couple of spikes, but you can see in the last 70 years, maybe, it has just been a dramatic spike, and it's not going up and down. There's a period of time when it was going up and down, but now we are just getting hotter and hotter and hotter. And now our average temperatures are going to be warmer than they used to be. So, I mean, when you look at this, you can say, okay, yes, temperatures have increased by 1 degree. Okay, that's sort of what it tells you, but what does that even really mean? Like who cares? Kind of is when you look at that. So if you look at this visual, we can see what that's changes. So right now we are at 1 degree Celsius global warming. And so you can see where things are getting warmer. So overall, this is an average, the 1 degree is an average, but that means some places it's going to be changing more than other places. So at an overall average of 1.5 degrees Celsius, you can see that at the northern pole, the northern Arctic of the earth, we're definitely getting warmer. So that's shifting. That's when people talk about the polar ice caps melting, because that part of the earth is getting drastically more warm. And at 2 degrees global warming, we can start to see that, like, that means that this here at the bottom shows you that this change in 1 degree Celsius results in a much in some places, an actually much bigger change. So it's like some places are going to be up to like 6 or 7 degrees change over, opposed to just like, it's not just 2 degrees, it's actually significantly more. And at 4 degrees Celsius, you can see that this world is like dramatically different compared to 1 degree. So even though it seems like it's a very small amount of change, this is overarching change. And this just has a huge impact on the earth. Not just a little impact, it has a huge impact, even though it feels like day to day, 1 degree isn't much, 2 degrees isn't much, but overarching, it is huge. Sorry. So understanding greenhouse gases is really important to understand how this happens. So this may be something that you've heard of before, hopefully, but if not, there is a natural greenhouse effect. So we call it the greenhouse effect. So if you've ever been in a greenhouse, you know that the sun comes in, it gets trapped by the glass, and then it's warmer in that environment. I also like to think about it if like I'm sitting in a car, and even in the winter on a sunny day, it can be warmer in the car because the sun warms up the air inside the car and traps it. And so it feels warmer in the car than it does outside because you don't have the wind, you don't have, your heat doesn't escape as much. The greenhouse effect, the window effect, the car effect traps the heat inside. So that's the same idea with the ozone layer. The atmosphere around the earth is that we trap some of the heat in it, and that naturally happens. That always happens, is that the sun rays, the heat radiation comes through the atmosphere and bounces off the earth, and then some of it bounces back to the earth and we continue to have heat. But naturally, a bunch of it also escapes. It doesn't just all stay in, but a bunch of it escapes. What's happened is that with human enhanced greenhouse effect is that we have created more greenhouse gases. So we have made the glass thicker, kind of. We've made the ozone, or not the ozone, the atmosphere thicker. And so now, instead of a lot of the radiation, a lot of the heat comes through from the sun, bounces off the earth, and then it bounces back in. Not very much of it escapes. So that's what's heating up our earth, is that because we have more of these pollutants in the air, our atmosphere is thicker and it's bouncing more of the heat back into the earth, which then that's having the impact on us. So the climate crisis, we're going to talk about the impacts on humans as well as impacts on the natural environment. So if the temperature rise cannot be kept within 1.5 degrees Celsius, we're already pretty much at a temperature rise of 1 degree Celsius. So if we go over another 0.5 degrees Celsius, the UK and Europe will be vulnerable to flooding caused by extreme rainfall. So it's not just going to get warmer, but parts of the world are going to get intense rainfall that's not been their experience before. Already right now, some places in the earth have monsoon season where they get a ton of rain, and then they have a dry season. But right now, this is going to be, with climate crisis, this is going to happen in other places of the world. Countries in the Middle East will experience extreme heat waves, and farmland could turn into desert. So there will be, that will have a dramatic effect on food production, because if you can just imagine green fields where we can grow things, just being cooked, being toasted, and becoming a desert means that we lose so much. Island nations in the Pacific region could disappear completely under rising seas. A lot of our coastlines will change as our seas get deeper and rising. Then that takes around, like that washes away coastlines. And so where do those people go? They have to move inland further, and there's this whole conversation about climate crisis refugees in terms of people who are going to be losing their homes to the climate crisis because the ocean levels are rising and their communities, their towns, their cities are being washed away. Many African nations will likely to suffer droughts and food shortages. So some places will get extreme water, other places will not get any water. Drought conditions are likely to happen in the Western US and most likely Canada as well. And other areas will get really intense storms. So even, I think many folks have noticed this, that our weather patterns have really been shifting the last few years, and we're getting really, really intense storms, really intense hurricanes in different places. And that's having a really big impact because of this whole interconnectedness of the earth, which the climate crisis is impacting. And again, domino effect. And then Australia is likely to suffer extreme heat and drought. If you think also like in terms of the forest fires and things that have happened in the last few years, that as a result of extreme heat and drought, not having any water, it being really hot, leads to rampant fires, which is really concerning. So then we also have impacts on the natural environment. So not just our human communities, but on the nature and the environment as well. So one example is the Great Barrier Reef in Australia has already lost half of its coral since 1995. So that is almost 30 years, and we've lost half of the coral. Like that coral is a creature that has died like that. And the Great Barrier Reef is huge. This is due to the seas being warmer, and the animals just are not, the aquatic life just can't survive because they're not built for that temperature. And so therefore they are dying off. Wildfires, as I mentioned before, are becoming more and more frequent as climate change increases the risk of hot, dry weather. We are even impacted in our area in Northwestern Ontario. We have experienced, and many of our communities have experienced forest fires or experienced smoke from forest fires being close, and that has an impact on us. As frozen ground melts in places like Siberia, greenhouse gases trapped for centuries will be released into the atmosphere, which that worsens the climate change. So because the ice and the ground is melting, that has trapped different gases, with those melting, those are releasing. And that naturally happens sometimes, but it's unbalanced now because of the impacts that we have had. And then animals will find it hard to find food and water. So polar bears are a common example, could die out, they could become extinct because the ice that they rely on melts away, and they can't find food, they can't get to where they need to be. The same with elephants who need a significant amount of water, won't be able to find the water that they need, and then therefore they are likely to become extinct. And then, so scientists believes that 550 species of animals could be lost this century because of the climate crisis. So that's a lot of animals that will never be recovered again. That's a really big shift in ecosystems, and as things as a whole, that's really going to change the environment. So now you can do key questions on page 15, the check your understanding question through 3. And let's do a quick recap before we run out of time. So this is lesson 2, the effects of human activity on soil, water, and air. So for soil, we talked about deforestation, urbanization, erosion, chemical fertilizers and pesticides, and then industrial chemicals destroying the soil. For water, we talked about how recreational, industrial, and everyday human activities pollute water. And air, we talked about the burning of fossil fuels leading to air pollution and the greenhouse gases effect, and therefore climate crisis being a result, and having detrimental effects on both humans and the natural world. So our success criteria for this lesson are: 1, I can explain the impacts of deforestation, urbanization, erosion, chemical fertilizers, pesticides, and industrial chemicals on soil. So hopefully you can do that. 2, I can explain how humans create water pollution. 3, I can explain how the burning of fossil fuels creates climate crisis and the impacts of humans on the humans and the natural environment. So hopefully you were able to do all 3 of those things with it because of this lesson. So now you should know the key questions on page 17. They are the review questions 1 through 11. And as always, if you have any questions, please reach out to me. I'm happy to chat about these things. This can be kind of intense conversations to be having and to be doing on your own. So I'm happy to text or email or talk on the phone in terms of working through the thoughts about these things and the impacts that we have on the earth and the things that we can do to improve and hopefully shift our earth in a way that is sustainable and healthy. You can get a hold of me on the phone at 807-737-1488 or toll free 1-800-667-3703. You can email me at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at B-Slate Wahsa. You can watch the replay of this and connect to some of the other videos if you'd like at my YouTube channel on B-Slate Wahsa. My office hours for this term are Monday through Friday, 9 to 4. So that's the best time to get in touch with me if you like. As always, thank you so much for joining me today. I hope you learned something and that this was helpful for your completion of your key questions. Miigwech.